Welcome, Algebra 2 to horizontal asymptotes. Let me get that mouse pointer out of the way. Horizontal asymptote is just like what we talked about yesterday, except horizontal. So it's a horizontal gap in the graph. Remember, we're talking about gaps in the graph here. So I'm going to give you guys an example. We've got the same example as we did on the other side of the page. Same little guy there. Except this time we're going to find that horizontal asymptote. Well, that says +4. Trust me. You know what? I'm going to rewrite that. That says +4. Yay. And this value right here, the K, is your horizontal asymptote. You don't have to flip the sign. You don't have to do anything to it. That's just it. So you're going to write y equals 4 as your horizontal asymptote. And in a more general terms, y equals K. So for this particular function, it's going to look something like this. It's going to go vertical at -1, or almost vertical, excuse me, and then almost horizontal at 4. And then on this side as well. Something like that. Simple enough if it's written like this. What if it's written as one giant fraction? And then you've got to find the degree, which is the largest power of x. We've talked about that before, in the numerator and denominator, and use this chart to figure out what it's going to be. Start out by looking at the degree of the numerator. So find the biggest power of x. Look just at the top. Well, there's only x, just x. We'll call that degree 1. That's basically x to the power of 1. But on the bottom, my biggest exponent, or power of x, is 3, so this is going to be the degree 3. Now we got to figure out, is the numerator a bigger degree? Are they equal degrees? Or is the numerator a smaller degree? Well, if I'm comparing 1 and 3, which is bigger? I mean, 1 is less than 3. So that means, I'm going to be using this here, 1 is less than 3. My horizontal asymptote is at 0. So I would just write horizontal asymptote y equals 0. Let's try another one. Find the horizontal asymptote if any of each function below, and I want you to cross out, then find the range. Sometimes it's a little bit more complicated than that, depending on the function, so we're just going to talk about it in class. Just cross that out. We're not doing that in the video. So first start out, compare the degree of the top and the degree of the bottom. This is actually just like this example. This is degree 1. This is degree 3. And 1 is less than 3, which means, oh, 1 is less than 3. My horizontal asymptote is at 0. So horizontal asymptote is at y equals 0. Huh, that's it. Let's try the next one. So see if you can figure out what degree is the top. And hopefully you said it's degree 5, because the only exponent is 5. Degree 5. And the denominator, go ahead and see if you can figure out the degree there. And I hope you said degree 3, because that is the biggest exponent, or biggest power of x. And then let's compare 5 and 3. I always start with the numerator. Notice that I've always started with the red one. So 5 is greater than 3. So check out your chart, find the greater than part of the chart. Oh, here it is. There it is. So if the numerator is a greater degree than the denominator, I have no horizontal asymptote. Don't put 0. Well, guys, guys, as you can see, I now have a blank paper in front of me, and that's because my screen recorder extension just crashed in the middle of the video. So let's see where we were, shall we? We had degree 5 and degree 3. And I think I was just in the middle of telling you that no asymptote is not the same as an asymptote of 0. So we've got horizontal asymptote, none. We have no horizontal asymptote. All right, so if you get the degree on top bigger than the degree on the bottom, that means no horizontal asymptote, not 0. Don't put 0. This means your graph could still have a vertical asymptote, or it could have something called an oblique or slant asymptote, just not a horizontal one. So that was the rest of that one. And then we get on to example 3 and 4, which I have already recorded, and now I get to re-record. I'm very happy with that, as you can see. So example 3, let's look at our degree. Degree 1. And also degree 1. I'm using the wrong color. See, that's what happens when I have to re-record something that I just recorded 10 minutes ago, because the computer crashed on me. So when you have 2 degrees equal, so degree 1 equals degree 1, you are now in the middle section of that chart. And here is where, if you're going to make a mistake, this is probably where you're going to make it, so don't make it. When you get your horizontal asymptote here, you are looking at the coefficients, not the powers. That's a mistake people always want to make. They want to take degree 1 and degree 1 and make a little fraction out of degree 1. And they always get horizontal asymptote is 1 over 1. It's not. Take the coefficients. I want you to write this real big. Coefficients, not powers. You are going to make a fraction out of the coefficients, not the powers. So let's look at the coefficients. Coefficients, 2 and negative 5. So your horizontal asymptote is y equals 2 over negative 5. Not 1 over 1. Coefficients, not powers. 2 over negative 5, which is negative 0.4. So why don't you try that again on example 4. First, figure out the degrees. Hopefully you said they're both degree 3 on the numerator and denominator, so the degrees are equal, and we are in the center section of this chart, where you will now look at the coefficients, not the powers, and put them in a ratio. Go ahead and do that. And I hope you got that your horizontal asymptote is at 4 because you looked at the coefficients, not the powers, of the numerator and the denominator of the highest degree or highest power of x. You get 4 over 1. Those are the coefficients, not the powers. Ignore them. 4 over 1, which simplifies to 4. Well, and that is, for the second time for me anyway, about it for horizontal asymptotes. Thank you for watching.